So in continuation with the K-map, the last topic I'll cover is this don't care condition, represented don't care condition, and this don't care represented by a cross. What do you mean by this don't care? Let me explain this with the help of an example. For example, suppose I take a OR gate or a simply a two input OR gate where you have two inputs A and B, and suppose I say that the output of OR gate, as we know, it is Y, and say it is equal to A plus B. Means it's a OR gate here. Here it is a OR gate. You know symbol of this OR gate. Two input. I'm taking only two input. Then it can be n number of inputs here. So the two inputs are A and B, and of course the output is A plus B here. The possibilities are 0 0, 0 1, 1 0, and 1 1. And I know that in case of OR gate, this is 0 and rest all are 1. If any one of the input is 1, the output is 1. Now I can express this truth table in a different way, or I can short this truth table. Just see that I take the two inputs A and B. Same. I take two inputs. Equivalently, I can write this as two inputs A and B, equivalent of this. And this Y is A plus B, of course. If you see that this 0 0 is 0, same I'm writing here, this 0 0, the output is 0, and I say that if A is 1, now see, this A is 1, the B can either be 0 or 1, the output is 1. So whether the output is 1, whether the value of B is 1 or 0, and I represent this by a cross. This is called a don't care. Means this output does not care about the value of B if the value of A is 1. This is called a don't care condition. Let's take another example. Suppose I have two inputs. Let's take for an AND gate. Suppose you have two inputs A, B, and this output is A dot B, which is an AND gate. Of course, the possibilities are 0 0, 0 1, 1 0, and 1 1. For a AND gate, 0 dot 0 is 0, this is 0, this is 0, and this is 1. Now equivalently I can write this as, again, the two inputs. Suppose I have two inputs A and B, and suppose here I say that the output is A dot B. Now I am writing this element first, this row first, that is 1 dot 1 is 1, and if the value of A is 0, or even if the value of B is 0, we don't care. If the value of A is 0, B can either be 0 or 1, the output is 0. So the output is 0 whatever the value of B is, or suppose if B is 0, what I put a cross here. So this is called a don't care condition. If A is 0, this output does not care about the value of B. Whether 0 or 1, the output will be 0 only. Such conditions are known as don't care conditions. Now let me do one or two problems based on don't care. And I'll make of these don't cares, I'll treat them as either 0 or 1 as per my convenience. I'll write a problem here. Let's deal with the problem. Suppose I say that simplify, say f is a function of three variables A, B, and C, and suppose I say that this is equal to summation. Let's take summation of certain min terms. Say it is 0, 2, 4, 5, plus, say you have a don't care. This D stands for don't care, and it is don't care, say 1 and 7. Now see, look at the solution of this. How will I solve this? First of all, I frame a K-map for three variables, and I've told you how to frame K-map for three variables. I take a rectangle or a square and divide this into 8 equal cells. Since this is for min term, I make this for min terms. On one side it is AB. I write here A bar B bar. This is A bar B, AB, and AB bar. And of course this is C bar and this is C. I write decimal equivalent 0, 1, 2, 3, 4, 5, 6, and 7. And now what I do, I substitute a 1 on these minterm positions, that is 0, 2, 4 and 5. Forget about this. Had it not been there, you had a pair this and another pair is this, and I can frame the simplified SOAP form of this. But since you have a don't care here, what I do, I substitute a cross on these don't care positions at 1 and at 7. Now I'll make the use of this don't care in order to minimize this. So in order to minimize this, I treat this as 1, and treating this as 1, I can make a quad here. I hope this is clear to you. And the value of this quad, I treat this as 1. This don't care as 1. It can either be 1 or 0. So for my convenience, I am using this as 1, and the value of this, if you see from this side, it is B bar. So it is B bar from this side. Now this 1 is remaining. The only group which is possible with this remaining 1 is this pair only. Is this pair, and the value of this pair, if you see from this side, is A bar and here it is C bar. So plus A bar C bar. This is my final answer. I need not cover this don't care. All don't cares are not to be covered. I'll treat them as a 0 because it will maximize the function. My target is to minimize the function, so I'll use K-map only. Only those don't care conditions which are helping in making a bigger group in order to minimize the SOAP form. I hope this is clear to you. Let's take one last problem, and I'll take a problem with a 4 variable using don't care condition. The problem is, suppose I say that simplify. Next problem, I say simplify f, which is a function of a, b, c, d, is equal to, I say it is equal to summation, say 0, 1, 2, 3, 8, 9, 10, let's take one more number, say 13, and plus I say don't care. You can have I say 5, 7, 11 and 14. Let's take these numbers here. Remember that 8 here and here at both the positions not possible. So I frame a K-map for 4 variables here. I'll frame a K-map for 4 variables, of course for minterms, and I'll write the decimal equivalent. First I'll divide this into 16 cells as we have done it many times. On one side suppose it is AB, and this side suppose it is CD. So it is A bar B bar, this is A bar B, this is AB, AB bar. Similarly here you have C bar D bar, C bar D, CD and CD bar. I write decimal equivalent 0, 1, 2, 3, C bar D bar, C bar D, CD, CD bar. Yes, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. And now I substitute a 1 and cross on the corresponding these and don't care condition. 0, 1, 2, 3. I substitute 1 here. 0, 0, 1, 2 and 3. On here you have 1. 8, 9, 10, 13. 8, 9, 10, 13 is here. And I don't care at 5, 7, 11, 14. Where is 5? 5, 7, 11 and 14. Now see, had this don't care not been here, I would have made this quad. But with the help of this don't care, I treat this as 1, and it is very easy for me to make a quad, an octet. Otherwise no octet was possible. So I frame a octet here. My target is to make the biggest group. So I frame this octet here, and the value of this octet I am writing here. The value of this octet from this side, it is B bar. From this side it is B bar. Of course B bar dot 1 because complete column is covered. Now this 1 is remaining. Had this don't care not been here, it would have been a pair only. But now since this don't care is here, so it is helping me in making a quad. If you see that it is possible for me to make a quad here, and with the help of this all the ones are covered. My target is to cover all the ones but not all don't cares, and the value of this will be C bar D, B bar plus C bar D. Now no need to cover these ones, these don't cares, leave it. These are don't care conditions, we don't care for it, we care for only those don't cares which are helping in making the biggest group. So I hope that this is clear to you. With this I come to the end of this unit, so thanks for the time being.